All right. So today we are going to be talking about the new changes, the update to the NFPA 70E, the 2024 edition. So this is a little bit early. You know, technically we're still in 2023, right? But we're going to get this kind of a head start to the changes so you know what to expect here. And with that, I'll go ahead and show you guys our presentation.
How is it possible, Caitlin, that you got your hands on a 2024 copy?
Well, I pre-ordered it. So I've got it right here, pre-ordered it. And so we're going to talk about the differences, mostly going to focus on the 2024 edition. I'm not going to pull up the 2021 edition too much. I'll reference a couple things, but we're just going to focus on what's newest and latest and best, right? So, all right. Let's get this presentation going.
All right.
Thank you guys for hopping on today. We really appreciate it. I know a lot of people are spending their time at the beach or the lake or something this time of year. So appreciate your dedication to learning more. All right. Introductions. My name is actually Caitlyn Weininger.
Yep. And I'm James Weininger.
Something happened there.
Yep.
And we're going to get started here. So first off, what is the NFPA 70E? We want to know what it's for, why it's important to know, and keep up to date with those changes. So this is going to be a really short crash course. We're going to go through a lot of different things, but you know, there's definitely longer training out there that you should probably get involved with and learn more if you don't have a strong familiarity as it is. So first off, I've got a couple poll questions. Are you familiar with the NFPA 70E? Is that something that you are familiar with? Yes or no? To any level. Most people are saying yes so far, which is good.
That's good.
Got a little less than half of our audience answering here. Give it just a couple more moments. And everyone so far has said yes. One person said no.
Okay.
Totally fine. You're in the right place. We will give you an update on it. All right. So next one. How often do you update your electrical safety program? Let me get that poll pulled up here for you. How often do you update your electrical safety program? Whenever a need arises, at least every 3 years, or it's been longer than 3 years. Let's see what the answers are. Okay, so kind of a mix, a split right now between whenever a need arises versus it's been longer than 3 years.
Yep.
Okay.
Hopefully that need isn't when an accident
happens. Yeah, good point. Good point. And then last poll, get this thrown up here. When was the last time you and or your team had electrical safety training? Kind of similar answers here. Less than a year ago, less than 3 years ago. It's been longer than 3 years. Got 7 answers so far. Pretty good split here. A lot of people said less than a year ago, which is good. That's fantastic. Keep up to date, guys. Been longer than 3 years. All right. So, like I said, my name is Caitlyn Weininger now, and I'm still same credentials though. Certified electrical safety compliance professional, electrical engineering degree background. Been with Herzig for almost 5 years. Actually, yep, right about the 5-year mark this time of year. So that's pretty nice. And I've got a lot of experience doing trainings and safety program work and things like that. So my whole job revolves around this standard, the NFPA 70E.
I'm James Weininger again. I have a similar background to Caitlin, although she went off to the training side and development side of things. I went off towards more of the engineering and codes and standards,
right?
Specializing. I'm a licensed professional engineer in 6 states now. Losing track.
It's getting
a lot of states. So yeah.
Goal is all 50, right?
Goal's all 50. That's
Some
right.
point. That's the goal. Yeah, and we both have experience, kind of overlap. You know, we started out as interns and kind of just had to get to know all the different things that we might need to do in the electrical safety world, whether it be studies or training or whatever have you. So, If you guys have any questions throughout this presentation, please do not hesitate to ask. That's what the chat box is for. If you have any insight or stories or, little anecdotes you want to share as well. But yeah, definitely any questions, feel free anytime.
Mm-hmm.
All right, so we've got 3 modules, kind of similar to our previous webinar setups. First off, what is the 70E? So we're going to do an overview of what it all entails and the hazards that it's trying to protect you from. We'll go through and get to know the 2024 edition specifically of the 70E in Module 2. So we'll swap over to the online version of 70E that NFPA has and just kind of walk through that. And then Module 3 will be, how do you get a head start on compliance? We're still in 2023, but 24 is just around the corner. So
right.
Let's get up to date and ready for that. All right, so Module 1, what is it? Well, it's important to note how it started. So OSHA, being our, some people think the big bad, but honestly, really good intent, recognizes that arc flash and shock are hazards in general industry as well as other specific industries. And OSHA requires employers to therefore understand industry standards and protect workers. Okay, so if there's a known hazard, there are industry standards or even OSHA regulation addressing that you need to know and follow. So the codes and standards related to electrical are the NFPA 70, so the installation requirements, the 70E, which is what we're focusing on today for the electrical safety requirements, and the 70B, which we did a webinar 3 months ago on reliability and safety requirements. Now, also note that one, the 70B, just also became a standard this year, so it's not a recommended practice. If you don't know much about it, go to our YouTube channel. We have a great kind of crash course similar to this, but on the 70B.
Right.
All right, so for the NFPA 70E specifically, it is the consensus standard for electrical safety. It's the standard for electrical safety in the workplace. When was it created?
1979.
1979. But why?
But why?
Yeah.
Well, that's a great question, Caitlyn. From my understanding, OSHA created or had some standards in place for electrical safety, and the scope was too large enough for them to handle, so they assigned out the NFPA to develop that.
Right. So essentially, if you know anything about OSHA regulations, it's quite a process to get it updated, to get it changed, which is not a bad thing. Whenever you think about OSHA reg, it's law. So you want to make sure that everything is exactly the way that you want it to be before you try to enforce it by law. So NFPA takes on the responsibility of being able to update and keep best practices available to people without having to wait years and years and years and years for OSHA to catch up with their internal regulatory process too. So in 1979, like James mentioned, it was created, but it was in a partnership with OSHA essentially, so that they would have safe work practices to point to that are also consistent with the National Electrical Code requirements. So what is its purpose, the overview and purpose? One thing to note is that, the 70E itself has information about what it's supposed to cover and why it is even existing. So in Article 90, in the introduction, it talks a lot about that. It has for many editions. And under the purpose, it says, the purpose of this standard is to provide a practical, safe working area for employees relative to the hazards arising from the use of electricity. All right. So that's what the text says. What are those hazards that it's covering, though? What does it mean by that? Well, if you look in the definitions and then also in one of the informative annexes, I think it was E. Nope. Anyway, one of the informative annexes, it has a breakdown of the different electrical hazards. So we've got electric shock, arc flash, and arc blast, a little description of each of them. So let's talk about what those hazards are real briefly. So first off is electric shock. What is that?
Electric shock is when basically current passes through the body from source of voltage to the ground. Yep.
So our little images here have different potentials, and obviously anytime it passes through your body, it can be damaging. if not life-threatening. So we want to avoid that. We want to isolate ourselves from that potential of current flowing.
Correct.
Okay.
Yeah.
All right. So that's kind of the crash course, high-level overview of what electric shock is. It's current passing through the body. It's going somewhere through you, not intended. Now, the arc flash and arc blast hazards are actually part of the same event. You don't always have an arc blast hazard necessarily. Those are kind of specific situations, but there are arc flash hazards in most every facility, or potential arc flash hazards, I should say. So let's say you've got 3-phase conductors and, copper, aluminum, whatever your system required, and something drops across and into that panel or that disconnect or whatever it is. In this example, it's a wrench that happens to cross the conductors. Let's break down what happens. So first thing would be blinding light, and that could be temporary, it could be permanent. It depends on whether or not you needed protection and were wearing it, or lots of different factors. I will say flash blindness is very common. I personally have not heard, talking with hundreds of different people that I've trained and they've experienced arc flash before. I've never personally heard a story where someone's been in an arc flash and hasn't at least momentarily been blinded. Okay, so expect that.
Gotcha.
You're going to get disoriented if you're in an arc flash. It's going to happen. Then it would be the pressure and sound waves. So technically those are part of the arc blast hazard. The sound waves, per the different measurements and tests, can consistently be loud enough to rupture an eardrum or cause permanent hearing loss. So always want to wear your hearing protection whenever you're in the arc flash boundary. But the pressure waves, yes, there are going to be some kind of pressure waves in an arc flash event. Whether it's going to be strong enough to pick you up and throw you across the room is not as likely. It depends on your system, though, your situation specifically. One of the main things, that the 70E talks about as far as arc blast hazard would be if you have a lot of capacitance in the system. The discharge of that capacitive
discharge.
Yes, that capacitive. I said it backwards. The capacitive discharge in an arc flash event can cause those extremely significant pressure waves and concussive shock waves, and it creates lung protection issues and all sorts of stuff. So that could be a potential if you have that in your system. And then we've got vaporized material. So in this example, it said copper vapor, but it could be any metal or any material that got so hot it vaporized and is in the air. So what's the problem with that?
The copper vapor?
Mm-hmm.
Well, you don't want to breathe that in.
No,
that's for sure.
Definitely not.
Primarily because it's extremely hot.
Yeah.
Your body's not really meant to absorb that much metal in other things, of course.
Lots of things. It's bad. Whenever something like this happens, it's loud, it's bright, it's just all sorts of chaos. What happens? What do you do whenever you get surprised?
You inhale.
Gasp.
Right.
Yes. So trying to get that inrush of oxygen to kick in your fight or flight instinct. But in that moment, it's not good air that you're breathing in. And then molten material, so anything that didn't quite vaporize. Shrapnel, if the pressure waves are strong enough for things that didn't melt or vaporize, it could blow apart things, blow things out. Basically, the little faceless guy in the bottom left there says it right. This could be the last wrench you ever see. Yep. So those are the hazards that the NFPA 70E mainly focuses on. Now, in the last edition, the 2021, it did bring up more information on those capacitors and trying to come up to speed a little bit more on those arc blast hazards. And there's some other things as well, but the main focus is the electrical shock and arc flash and arc blast now. So for identifying those hazards, right now we have a option to label shock and arc flash specifically. So the shock hazard levels are going to be based on the nominal voltage, the highest nominal voltage in the enclosure, and then you need to know the boundaries around that. But to determine the potential severity of an arc flash hazard, there needs to be an arc flash study performed. So get those nice little warning stickers and danger labels and stuff. They're not stickers, sorry, they're labels. So I've got another poll here for you. Do you have the electrical hazards identified for your equipment? And by that I mean arc flash and shock hazard labels. So the options are, yes, proper arc flash and shock labels are applied, which is the best possible option, but let's be real. Some equipment has been labeled, but not all. And then the last one is no, need to get that done.
Yep.
Which, fair. We got to start somewhere.
That's right.
Got 7 answers. Okay, we've got 70%. Even mix between yes or some.
Okay.
That's fair. All right. So let's do a quick overview of what the 70E entails. So aside from needing those labels to be able to know what the hazards are, how do you protect yourself from those hazards is also going to be very important to know, and that's what the 70E also covers. So chapter 1 is going to be our main focus for a lot of people. I rely heavily on chapter 1 and articles in that 100 series heavily. First off are the definitions in chapter 1, article 100 definitions. All the definitions are there. And then we've got application of safety-related work practices and procedures, just making sure that we set the stage. Hey, this is important. Here's why we need to follow the rest of this information. Article 110 talks about the general requirements for electrical safety-related work practices, and this is where you're going to see the electrically safe work condition requirement. If you can turn it off and verify absence of voltage, you must. That is not an option. You should turn it off every time you work unless, and then there's a list of very specific situations that you might be able to keep it on while you work, but that's not the goal. And then it continues on and talks about permitting and safety programs and making sure that training is taken care of and that you've got a good lockout tagout program, and the qualified people are the ones doing the work essentially and overseeing the work. It talks about the different emergency response training you might need, host employer versus contract employer responsibilities. Essentially, just because you subcontract out some work doesn't mean that you pass the buck of liability, right? You still have to make sure that if they're coming to your job site or your workplace, that they also are following safe work practices. Test instrument requirements, just all sorts of things, good information. Article 110 is your starting place if you've not had a safety program or a lockout tagout program before. And then we get into Article 120, so establishing an electrically safe work condition. Article 110 made it very clear that that is incredibly important. So Article 120 is completely dedicated to making sure that happens, that you know how to do it. You want to talk about that a little bit? A little bit of the lockout tagout principles and the type of equipment that you have. But whenever you get to de-energizing electrical equipment, what are those steps on a high overview?
You were doing great. Caitlyn, you can take this one.
Okay. Well, there's 8 steps according to the NFPA 70E. Well, those would be determine all sources, make sure that you identify everything, and then properly interrupt the load current. So shut off the equipment, and then open up the disconnecting devices. Wherever possible, visually verify that the blades are actually disconnected or that drop type breakers are fully withdrawn. Release the stored electrical energy, block or relieve stored non-electrical energy, so gravity or something like that. Gravity is a very often overlooked lockout hazard. Apply your lockout tagout devices. Okay, so we've gotten to the point where most people are pretty familiar. Okay, you know where to shut it off, Apply your lockout tagout devices, bleed off the energy. But then what? The most important part is to use that adequately rated portable test instrument to test for absence of voltage. There is a change in the verbiage for the 2024 edition for that specific step, and we'll talk about that later. But that's a very important step. And then, of course, if there's a need, induced voltage or stored electrical energy, sorry, that's the term stored, then apply your temporary protective grounding equipment. Okay, so those are the steps. That's what Article 120 is dedicated to, explaining all of that detail. And then Article 130 is work involving electrical hazards. So until all 8 steps are complete, how do you protect yourself? Or 7, if you don't need the 8th step. How do you protect yourself? So it talks about the different boundaries and permitting requirements, whether or not you even need a permit. So if you're just testing and troubleshooting, for example, it's pretty hard to do voltage measurement without the power on. You don't technically need a permit for that, but you should still have a job safety plan done. Still exposure to hazards, so fill out your job safety plan. Know your boundaries, know your PPE, all sorts of good information about how to keep yourself and others protected. Okay, and then that pretty much wraps up chapter 1. And then that is usually the bulk of what gets implemented into an electrical safety program. Now, chapter 2 talks about safety-related maintenance requirements. So some more specifics on the different types of equipment that you might be keeping up to date and some safety requirements for that, as well as chapter 3 then goes into safety requirements for special equipment. So more and more people are going to chapter 3 recently for safety requirements related to batteries and battery rooms, for example, in Article 320. Or, if you're going to be working with lasers for 330, power electronic equipment, laboratories, research and development, 350, and capacitors at 360. So those are also important. And then we wrap up the document with the informative annexes. So those are not technically part of the standard per se, the text, the required part, but they provide a lot of good resources and tools on how to actually implement what the standard does require. Mm-hmm. So super high level overview of what that 70E is going to entail. Now let's talk about how it's revised, because obviously it was published originally in 1979. What is the revision process?
Well, usually there's public input, mm-hmm. and then it's all taken in and reviewed, and then they make revisions, and it's sent back out for public comment. Yes. To make final revisions, essentially.
So they look over every single public input and comment.
Yeah.
Which means if you have...
That's a lot.
Yes, it is. I've sat in on a couple of the meetings, like whenever they had it over Teams or at an NFPA conference, and it's a lot. They go through everything in a lot of detail, and there's debate back and forth because you got to make sure that everyone's on the same page, that this is the best possible way to write something that everybody's going to have to be able to understand and follow, and that they're going to be able to interpret that actual requirement the right way. There's no gray areas that leave it open to doing something that really isn't good. So they really do. They pore over it, they vote, they have different revisions, and it happens every 3 years. So last one was the 2021 edition, and now we are on to the 2024 NFPA 70E. Okay, so to recap Module 1, OSHA does require employers to protect workers from electrical hazards. The NFPA 70E is the recognized industry consensus standard for those electrical safety requirements. So after the 2021 edition, once this was published, it was opened up for input, public input, and then went through the first draft and had the comments and everything, had its revision cycle, sort through everything, vote on it. To get the 2024 edition, there were approximately 240, I think it was like 239, 240-ish changes that gave us the new and improved 70E for this coming year. So with all that being said, now that we know what it is, kind of an overview of what it entails, what are the specific changes that you need to be aware of that apply to the 2024 standard? Well, first off, I want to make sure that everyone has access to a 70E. Preferably now, like as we're going through it, so that you can be making notes and stuff. But if not, how do you get access? And we're going to talk about that for just a brief moment. So far, we have a split between, yes, there's a previous edition, like a 2021 or something. No, you don't have a copy, which I'll show you how to get one. And then, hey, someone said, yes, they have the 2024 edition, either a physical copy or through what's called the NFPA link. And we'll talk about what that is. Okay. So first off, I recommend purchasing the physical copy, but that's just a personal preference. I still like being able to flip through the pages and make notes and tabs and all sorts of stuff. This is still pretty nice and new and fresh, but
As far as pricing goes, too, NFPA documents are pretty affordable.
Yeah.
Compared to the IEC standards. You can get a copy of the NFPA 70E for less than $100.
Yeah.
Right.
I believe so. So in the slide deck, which I am going to make sure that you have the handout available here. Let's get this shared. So because we are going to flip over to NFPA's website to show you, I don't have all the changes in the slide deck, but I've got these links so that you can either go purchase it. So this is the catalog where you can purchase a physical copy and then it'll get shipped to you. Or the cool thing that they have now is this NFPA link. So there's a subscription you can get. It's $12 a month for an individual. Essentially, you get access to any and all NFPA codes and standards online, and you can search through it. It's essentially like a PDF, but it's online, so you can't download it. But it's really nice to have that access. The search feature is really, really helpful.
Right.
So I recommend that if you're going to be using it a lot. For the meantime, for those who don't have access, don't have a copy right in front of them, maybe they're not ready to purchase the subscription, there is a free access online version. That's what we're going to be using today for this webinar. You can go to that link, make sure that you have an account. This is where the slide deck is going to be helpful. We've got the links in there. We've got instructions on how to make an account. Log in, click the free access, and let's go ahead and switch over to that and dive in.
And to be clear, we're not sponsored or affiliated with NFPA.
No.
But please buy their products.
Yes. Well, and it helps them. It helps them be able to continue improving and advancing these standards for public use.
Yeah.
You know, if they don't have
no such thing as a free lunch.
No. All right. So you go online, you sign in, you click this free access button, or you go ahead and subscribe to NFPA Link, which is a lot smoother to use, a lot easier to use. You can select a different edition, so they have previous editions available as well. Mm-hmm. We're going to do the 2024 version. You agree not to infringe on their copyright.
Make sure to read through all of that.
Yes.
Right?
Yes. And then we've got our online access. So let's go ahead and dive into those changes. I've got some brief notes here just to make sure that I don't miss anything. So first things first to note is that whenever you do the online access, the free online access like we're doing here today, all those nice little notes and highlights that show the changes are not there. So the NFPA link, I believe, will still show that. And of course, the physical copy has all the triangles and the dots and the highlighted text saying this changed. It calls out the attention to that. But we're just going to talk about it. So I'll point it out for you. So starting off, one thing to note across the standard is that it is now going to comply with the NEC style manual, which means that the organization and format of this document is going to be adjusted a little bit from what you're used to seeing. So for example, perfect example, Article 90 in the 2021 edition started out with the purpose, right? Ooh, let me get it to that page. So it started out with the purpose, but now every chapter has to have a scope. For every article, sorry. Every article has to start with a scope, and it's going to be whatever that article number is, .1. That's reserved for the scope only. So since in the 2021, 90.1 was the purpose, now purpose is 90.2, and they've added 90.1 as the scope, saying this article covers the use, application, and arrangement of the standard, which, you know, just helps break down a little bit more of what you're going to get out of each article.
You did the whole switcheroo there.
Yes. Yeah. So that's one of those kind of consistent changes that you're going to see. Things are just getting shuffled around a bit just so that whenever you open up any related NFPA 70, 70E, 70B standard, you know where to find things kind of on a general basis. Okay, so that's one of the big things. Just keep that in mind. Article references from the 2021 to 2024 probably have changed from what you're used to, which I know I used to be able to pull out specific article reference at the drop of a dime, but I need to reorient myself on that one.
Reacclimate.
Yeah. Another thing that changed across the board that you'll notice, and there's specific reasons for this. Anytime we talked about shock, it's now going to say electric shock. Specify the difference because there's other kinds of shock out there. And so they want to make sure that we are clear which one we are referring to. Because, again, back with the capacitive stuff, yes, there's electric shock, but then there was also the shock wave from the concussive force, which I was trying to find the...
So shock blast,
yeah.
Shell shock. They changed it to electric shock to avoid confusion with that, essentially.
Right. So even in the definition, it now says electric shock hazard instead of just shock hazard, for example. Okay. So another big change, or not really big, but just, best practice, needed to make sure it was clear. Whenever you look at a reference to another standard, especially if it doesn't have a specific date associated with it. Perfect example is IEEE 1584. Okay, calculations for performing arc flash analysis. Okay, if it just said IEEE 1584, there's 2002 and then there's 2018 version. So if it doesn't specify a date, it's going to mean the latest version.
Okay.
So you don't have to pick and choose. It's just you go look, see whichever's the newest. That's the one it's talking to.
SKM doesn't even allow you to run 2002.
Not anymore.
And its latest editions anyway.
Not anymore. So an example specifically, ASTM F3258-21. That's going to be talking about the protectors, the type of protectors that need to be put over electrical rubber gloves, dielectric gloves. It used to say in that standard, leather protectors. It doesn't now. It's just protectors. They have other types of material that are acceptable now if you look at that standard.
Doesn't mean you can't use leather, though.
Absolutely.
You can still use leather.
Yes. That's the most common, probably will be for a while, foreseeable future. But there are other options available that have been approved for that use. So now, again, throughout the standard here, instead of saying leather protectors, it's just going to say protectors. So it means leather or other approved gloves that you put over the rubber gloves.
Right.
Okay, so those are some general things that got changed across the whole standard. Diving into Article 90, of course, we've got the scope added. We've also got references without specific dates, meaning it's just whatever the latest standard is. And it mentions some new wording, like workplaces not covered, instead of just saying not covered in general. It does have some limitation. Not every single industry or application is going to have to follow this. They might have their own specific code or standard, for example. Okay, so let's dive into Chapter 1 now. Article 100, the definitions. Again, it includes a scope. One thing to note about these definitions now is you need to look at the end of the definition for an article reference. So all of the definitions throughout the standard have been moved into Article 100, this definition section, okay? Previously, like in the 2021, they had these definitions that, whatever you found here applied to the rest of the standard. And then in the location that it talked about something specific, right before that, they would have the definition for that specific topic. Now it's all moved to Article 100, again, to comply with the NEC style manual. And at the end of the definition, so for example, authorized personnel applies specifically to Article 320, that definition does. Or battery effect is specifically going to be used for Article 310. Another thing to note, and this has already been there, but in brackets, it talks about 70. So if this is a example, attachment plug or bonding conductor or jumper or just bonding, those are definitions that also are the same in National Electrical Code, so the NFPA 70. So that's good to know. One definition I want to point out that is new is competent person. So a lot of people have used the term competent person. Now, technically, at the end of this definition, we see here that it says specific to Article 350. But if you read it, I think it makes sense. A person who meets all the requirements for a qualified person, okay, and in addition, is responsible for all work activities or safety procedures related to a customer special equipment, that has detailed knowledge regarding the exposure to electrical hazards, the appropriate control methods to reduce risk associated with the hazards. Sorry, that's top of the page there. And the implementation of those methods. So kind of, if you think about it this way, conductive or competent person is a step above qualified person. And I've talked to a lot of people that would consider it the opposite. But no, it's a qualified person who has additional knowledge and responsibilities on something very specific or special. Okay, so that's good to know. Another thing is that throughout the definition section for free access, or not free access, for the NFPA link version where you can actually search it, they arranged the name itself. So, you know, conductor bare, conductor covered, conductor insulated. That's how it is in the style manual. And then right after that in parentheses is how someone would normally say it or type it. So bare conductor, covered conductor, insulated conductor. So they've added those in just to make the search feature on NFPA link even easier. Another new definition that I want to call out is field evaluated, because I think people want to know about how do you evaluate if custom equipment is acceptable or not. So an evaluation of non-listed or modified equipment in the field that is performed by persons or parties acceptable to the authority having jurisdiction. So again, it still boils down to that authority having jurisdiction being able to sign off on it. There's some more boundaries that you need to be aware of, like the hearing protection boundary and the lung protection boundary associated with those potential capacitive discharges in an arc blast situation. But let's go ahead and jump to Article 105. So again, there's some new definitions, some rearrangement there. Article 105, mostly just housekeeping stuff, just making sure that the scope's added and that things are referenced properly. Article 110 is where we get into the first set of other than just housekeeping type changes.
Right.
So first thing to notice is that the electrically safe work condition policy requirement is 110.2. It's been moved up. It is right there in your face. Cannot miss it right after the scope. Only reason it's not .1 is because they have to put a scope in it. It's very important to have this policy to always require hazard elimination first. It's the first priority. And then, of course, comply with the rest of the standard as well. So that's been moved up. Really want to emphasize the importance of electrically safe work conditions there. And then another thing to note is that normal operation of electric equipment under your risk assessments and understanding of possible issues. I lost my article reference. I forgot to write that one down. Is mentioned as being very important as well. Basically, under normal operating condition, or yes, normal operation of electrical equipment, it talks about making sure everything's installed properly, it's rated properly, all the covers are in place, such and so forth. But it's added some more information that also follows the NFPA 70B as far as proper maintenance. So keep that in mind. As long as you're following the 70B, you've covered that as well. The job safety planning section. So next page, I believe. Yes, so job safety planning and job briefing, add a new item. So hopefully we're all familiar with what's required with that planning. It's completed by a qualified person, it's documented, and it includes a bunch of information. But it also now requires this new line here for part or bullet point F or whatever you want to call it, is an emergency response plan. that was always best practice, and it was, talked about. Yeah, certainly in any training I would give, it made sense to include your emergency response plan in your job safety planning. But now it's listed there in black and white. You got to include that. Okay. Let's dive into Article 130. So 120. Yes, I said that wrong. Now, another thing to note about the free access, it's not quite as easy to use as NFPA Link, so I definitely need to get on the bandwagon there. Okay, so for the lockout tagout portion of Article 120, it does have another informational note about locating sources and stored energy and things like that to make sure that you're not overlooking other types of hazards. There are more types of stored electrical energy, for example, than what they specifically mentioned here. There's not just capacitance. So making sure that that's covered as well under the elements of control with their stored energy. Another change is that electrically safe work condition process that I talked about earlier. And I'm going to tell you what the significant changes here that you need to be aware of. So not only do you need to follow those steps as usual, but under using that adequately rated portable test instrument that I talked about to test for absence of voltage, it now says, instead of just test for absence of voltage on each conductor or circuit part, it says to do that at each point of work. So what does that mean? You have a disconnect, you have a panel, you're going to get into the panel, you shut off the disconnect. On the load side of that, you measure and it says 0 on all three phases, phase to phase and phase to ground. Great. Now you still need to verify absence of voltage in that panel itself. So at the point of work, you have to verify absence of voltage, not just that disconnect point. Okay, it's very important. Clarify that. It's always been a best practice again, but now it's in black and white. That's what you need to do. So it says it right there on bullet point 7. Okay, and then there were some other changes, but diving into Article 130 here, we'll move right along. This has the most as far as changes are concerned. One of the things that you might notice are the boundary table values. So those have actually changed just ever so slightly because of rounding errors, essentially. Instead of just saying 3 meters, it says 3.1 meters now. Because before the conversion from feet to meters, it was like 3.04 something or whatever. So typical convention, you round that down. That makes sense. But that left just a tiny little bit that's technically part of the limited approach boundary, not accounted for in the meters measurement. So they put it round up, 3.1.
So you get a little bit more.
A little bit more rather than a little bit less.
That's right.
Be conservative about it. So that's good to note. Another thing about this information is that you should be taking into account the elevation. So the restricted approach boundary is based on an elevation not exceeding 3,000 feet. For higher elevations, adjustment of the restricted approach boundary shall be considered. So why would that be? Why would the elevation change your shock hazard boundaries?
Well, less atmosphere requires less current to travel through.
Right. The air density is less. There's less of it to have to go through I forgot the term. There's a specific term.
Breakdown voltage.
Breakdown voltage. Yes, it takes less for that.
Yep.
So your boundaries might actually be further if you're at higher elevations. So that's kind of an interesting note. Clarification there. There is also another note added here. Informational notes are for informational purposes only. They're technically not required part of the standard, but it's important to understand a little bit of background behind the standard. So they have a new informational note here that says, in most cases, closed doors do not provide enough protection to eliminate the need for PPE in situations in which the state of equipment is known to readily change. So if you are let's say, racking in or racking out a piece of equipment, just because the covers are on does not mean that you can go without PPE, for example. Another situation would be those disconnect switches that just have that little hook that keeps the hinge door on. There have been times, yes, very technical terms here, a little hook. There have been times that an arc flash occurs and it pops the door open because that latch is not strong enough to keep that door shut in an arc flash situation, a faulting situation. Certainly, if you don't have all the panel cover screws in place and secured properly, even if it is arc rated equipment, that could cause the cover to come off. So it's just saying, be aware, just because it looks closed does not necessarily mean that it's going to contain the hazard in a faulting condition every time. Okay. One thing that we use or have always done is make sure that our arc flash warning labels are durable. They're going to withstand the test of time. Make sure that it is going to be there when you need it. But now the standard actually does require that. On my copy, it has it shaded right here on the kind of middleist page on the right. The label shall be of sufficient durability to withstand the environment involved. Okay, you can't just slap on a paper printout and call it good. Okay, it has to be able to withstand the environment that it's applied in. So that's good to note. Okay, question that we get all the time. What do you do when you don't have PPE rated high enough to withstand the arc flash hazard that has been calculated? What do you do? How do you handle that? Well, there is a little bit of information here about the other risk control methods that you might use, because PPE is, the last line of defense, not the first. So essentially what it's going to be telling you is you need to find another method, another way to get yourself away from those hazards. So it could be remote racking or remote switching, for example, implementing some other kind of risk control method. All right, and then let's go to Article 130.8. Under reclosing circuits after protective device operation. There's some information in there that I'd like to point out.
Okay.
Oh, wait, one more. Bear with me here. It's talking about the different tables and whatnot. Okay. So if you have to, wait.
Right column.
It's the right column, not the left column. Yes, thank you. Reclosing circuits after protective device operation. So a breaker trips. What it used to say is that you should not re-energize until you determine it can be safely done. Now it specifies that a qualified person or persons, maybe a team of people, all qualified, make that determination. And that you should not, manually, I'm just going to read it. Manually reclosing circuit breakers or re-energizing circuits through replaced fuses shall be prohibited until the fault has cleared. So you have to identify why it faulted before turning it back on. This whole idea of, oh, the breaker tripped. I don't know why. Let's just turn it back on and we'll see if it trips again and then we'll investigate. Not a thing. Don't do that anymore. If for some reason it was an overcurrent device that involved automatic operation because of an overload rather than a fault condition, and you know it was an overload, that's a little different. There's that exception listed right underneath it. But other cases, don't just turn it back on and see what happens. Okay, make sure that that fault has been cleared. Okay, and it says right there in black and white. Again, a lot of these changes were best practices already, but they're just making it very easy for us to say, no, you really need to do that. Okay, and then there were some other changes. I'm getting all tied up in the details here. I need to look at the time. There were some other changes in Article 130 about the DC systems and the PPE category tables for that. It used to be split up into two different tables, but now it's one, and it's just for 150 volts to 600 volts with all the other types of specifications. And And then there's some other information that's changed to help with more specific situations. Chapter 2 had mostly housekeeping stuff involved with the changes. Not a whole lot to point out there. Chapter 3 had some specific things added as far as the scope for hazard protection with DC hazards, which I'm going to actually spend a little bit of time calling that one out, because previously it said it was consistent with AC. It was 50 volts AC, 50 volts DC. Now it says under 320, which is talking about safety related requirements for batteries and battery rooms. It's 50 volts AC and 5 milliamperes, or 100 volts DC and 40 milliamperes. Those are the hazard thresholds for specific research that has been done to determine that those are really where we need to be concerned. And then to be consistent, Article 330 also had those changed. Article 340 had the scope expanded, 360, so on and so forth, housekeeping. The annexes, they also had some changes just for housekeeping purposes. Very good information, very helpful, but nothing major to point out as far as a change, except that there's a new annex. So Informative Annex S, assessing the condition of maintenance. It is helpful. If you read through it, it provides some good starting places to think about. If you're following the 70B, I personally don't think that the Informative Annex S is needed. If you're following and utilizing all 3 codes and standards in that little triad that we like to group together so closely because they do tie together so closely, then Informative Annex S is just a high-level reinforcement of the requirements in 70B already. So assessing condition of maintenance, making sure that you know for risk assessment purposes, is it going to be safe to use?
Well, in S.8 at the bottom, it actually discusses that you should read the NFPA 70B
right
anyway, so.
Right. So making sure, and it says here 70B is an example of a document that contains further information. That's because it's not the only document. Remember, if you've watched the video or the webinar from a few months ago, we mentioned some other standards that you should be looking at as well. 70B is just the NFPA's version that has a lot of good references as well. All right, so let's go ahead and get to our wrap up here. We'll conclude this training. 2024 edition had quite a few revisions and additions made. And with the limited amount of time, there really wasn't opportunity to get through every single little addition and change that's made. Obviously, if we've got, what did I say, like 230?
Over 200.
Yeah, a lot. That's going to take more time and effort to get familiar with it and actually make it memorable. So go ahead and get yourself a copy of this edition. Whether it be online or a physical copy, make sure that you have access to it and keep up to date on these changes that have been made. All right, so module 3, let's close it out here. How do you get a head start on compliance with the 2024 70E? What do you do now that we have this update? Well, straight up, audit, update your electrical safety program. Make sure that you provide updated training to the employees and the management that have to follow your electrical safety program. So again, get a copy of the 70E, get familiar with it. There's also a handbook available or will be available in September. I'm pre-ordering that one too, as long as it gets approved. Don't see why not.
Early bird gets the worm.
Oh yeah. Can't wait. Once you get familiar or get a copy, get some access to that standard, the 2024 edition, go ahead and audit your safety program. Go through it, make sure the definitions make sense, make sure that your policies and requirements line up with what the 70E requires at a minimum. Go above and beyond, by all means, but at a minimum, make sure that it's following what this is requiring you to do. And then once you've got that updated, make sure that you train and retrain your employees and management. It's required every 3 years anyway. So if you audit your program now and update it now and then retrain now, then the next time you need to do the retraining, unless something's changed at your organization to prompt sooner training, or for that individual, then you're going to be on set with the revision cycle. So next time you need to audit and update will be the same time that the 2027 edition comes out. So if you get yourself on that 3-year cycle now, it's just going to help you in the long run.
It'll help for budgeting purposes, of course, too, if you can plan.
Oh,
ahead.
yeah. Oh, yeah.
Planning is everything, of course.
Yes. Now, if this seems like a lot, or if you've got a million fires to put out already, metaphorical fires, I hope, we can help. If you need the help, we've got you covered. We've got our resources, our code and standard nerds that can go through your safety program and help make sure that it's all buttoned up to date, remove the gray area for who's qualified, who's not, what can they do, best risk control methods, as well as just keeping it applicable to your workplace. There have been a lot of times that I've been asked to review a safety program, and I open it up and it's essentially a copy paste of what the 70E says. I can pull up a copy of the 70E and I pull up their safety program, and certain sections of it, it's word for word. I'm like, okay, I get that, but it's telling you what you need to do. Your safety program should be how you're going to do that. Your specific people, what are they wearing? What are they doing? Who's in charge of what? Implement that, make it specific to your operation. So if you need help with that, that's something else that I do as well. Plus there's training associated with that to make sure that everyone who needs to know that information gets their questions answered and they know how to utilize that. Okay, so last poll before we wrap up here. What is the main reason we need to talk about electrical regulations, codes, and standards so much? Know how to stay compliant and avoid fines, give safety professionals more to worry about, or avoid electrical injuries and fatalities. Hopefully this is a pretty easy answer for everybody. This is a pop quiz. You are being graded on this. Okay, everybody so far has gotten it right. It's to avoid those injuries and fatalities.
Bravo.
Yes, we want everyone to be able to go home safely every day. All right, with that, we are wrapping up here. If you have any questions, go ahead and shout them out here. If you want to talk more offline, because I know that we are also getting right up to the end of this webinar time frame, there's our contact information as well. You can email us. Mine is still technically chetzel@herzigengineering.com, in the process of changing that, but that will still work. James J. Weininger at herzigengineering.com,
Yep.
or you could just call or email the office in general and talk to somebody else. We've got tons of people here who are ready and willing to answer any questions you have. But I'm going to hang out for a little bit. If you guys have anything that you want to ask about or go over in more detail now, especially since I just had to skim over some of this stuff, we're going to let other people go. But thank you so much for attending. Charles, Nick, thank you for interacting in the chat as well. Makes it helpful to have some input that, yes, you are alive and listening.
Yep.
So let's see. Oh, Charles, good. We've got you taken care of with the arc flash labeling. That's fantastic. If you ever need any questions, there's a lot of information in those reports that, if you aren't sure what it means or how to use it, give us a call, send us an email. We'll help you out with that. Thank you for a very informative crash course. Will Herzig be presenting the electric arc flash training webinar again or make it available? Okay, so with this webinar, it's been recorded and we're going to go ahead and get it posted for anybody that missed it. Ricky, thank you. Appreciate you coming. And if you need a more extensive arc flash and electrical shock, or just in general electrical hazard safety training, we can definitely get you taken care of. We'll reach out. All right, and with that, we thank you for your time, guys.
Thanks, guys.